There is a version of this CKA task that takes 90 seconds, and a version that quietly breaks the cluster you are being graded on. Today, add a storage class, set its binding mode so volumes wait for the pod that needs them, and make it the cluster default. The interesting part is that last word. Default is an annotation. Only one class is allowed to carry it, and you are told not to touch anything that already exists. Here is the setup. The cluster already runs a dynamic provisioner, and there are already storage classes using it, one of which is marked as the default. 3 things are asked of you. Add a class called fastLocal that reuses that same provisioner and binds with WaitForFirstConsumer. Make fastLocal the cluster's default, which means exactly one class ends up carrying the marker. And do all of that without editing any existing deployment or persistentVolumeClaim, because there is a workload here already using storage, and points come off if you disturb it. 2 mechanics to have straight before typing. First, binding mode. Immediate means the provisioner creates a volume as soon as the claim appears, before anyone knows which node the pod will land on. WaitForFirstConsumer means the claim sits pending on purpose until a pod that mounts it gets scheduled, and only then is the volume created on that pod's node. For node local storage, that is the correct choice, and it is what this task asks for. Second, the default. It is not a field in the spec, it is an annotation, storageclass.kubernetes.io/isDefaultClass, set to the string true. It only affects claims that name no class at all, and a cluster with 2 of them is misconfigured. So the order matters. Take it off the old class first, then give it to the new one. Read the cluster before changing it. There are 2 classes already. Both use the same provisioner, rancher.io/localpath, which is the one the task tells you to reuse, so there is nothing to install. Standard carries the default marker, and it binds with WaitForFirstConsumer. Bulk HDD binds immediately and is not the default. Note which one is default, because that is the class you will have to take it away from. Then look at what you must not break. The ledger namespace has a claim that is already bound through standard, with a deployment running on top of it. Now the class itself. In the exam, open the storage class page in the Kubernetes docs, copy the example, and delete everything the task did not ask for. No parameters, no mount options, no reclaim policy. What is left is 4 lines that matter. The name, fastLocal, the provisioner, copied exactly from the class that already exists, because reusing it is the whole point. And volumeBindingMode set to WaitForFirstConsumer. Apply it, and the class is created. Notice there is no default annotation on it yet. That is deliberate, and it is the next step. Before handing the title over, take it away from the current holder. A 1-line patch sets the annotation on standard to the string false. kubectl edit gets you to the same place if you prefer an editor, and in the exam, either is fine. Look at the list now. Nothing carries the default marker. That is a perfectly valid state, and it is much safer than the alternative. Because if 2 classes claim to be the default, Kubernetes cannot choose between them, and an unqualified claim will not get a class at all. Same patch, other direction. Set the annotation to true on fastLocal. And now read the list the way a grader would. Exactly 1 class shows the default marker. It is ours. The provisioner matches the one that was already in the cluster, and the binding mode says WaitForFirstConsumer. Every requirement of the task is visible in that single line of output. If you had baked the annotation into the YAML when you created the class, you would still have had to unset standard, so the order of operations is the thing to remember, not which tool you used. Let's prove both halves for real, without touching anything we were told to leave alone. Here is a throwaway claim in its own namespace, with no storage class name at all. Create it, and look at the class column. fastLocal. Nothing told it that. It picked up the default, which is exactly what the annotation is for. And the status is pending. That is not a failure, and this is the part people panic about in the exam. Describe the claim, and the event says it plainly, waiting for first consumer to be created before binding. The volume does not exist yet, because no pod has asked for it yet. Now create the first consumer, a single pod that mounts that claim. The scheduler places the pod, the provisioner creates the volume on that node, and the claim goes straight to bound with a real volume behind it. That is the entire point of WaitForFirstConsumer. The storage follows the pod, instead of the pod being dragged to wherever the storage happened to land. And the last check is the one the task actually grades you on for part 3. The ledger namespace is exactly as we found it. Still bound, still through standard, its deployment still running. We changed which class is default, without editing a single existing object. Things worth carrying into the exam. Copy the storage class example from the docs, and delete every field the task did not mention, because extra fields are extra chances to be wrong. Reuse the provisioner string exactly as it appears in the existing class. Do not type it from memory. Remember, the annotation value is a quoted string, true, not a boolean. Always unset the old default before setting the new one, and confirm with getStorageClass that exactly one class shows the marker. Do not try to move an existing claim onto your new class. A bound PVC storage class cannot be changed anyway, and here you would be modifying an object the task explicitly protects. And if a new claim sits pending on a WaitForFirstConsumer class, that is the design, not a bug. To recap, we read the existing classes, reused the provisioner that was already there, and created fast local with WaitForFirstConsumer. We took the default annotation off the class that had it, then set it on ours, so exactly one class carries the marker. We proved it with a claim that names no class. It landed on fast local, waited pending until a pod consumed it, then bound on that pod's node, and the workload we were told not to touch never moved. Binding mode decides when the volume is created. The annotation decides who gets picked when nobody asks. Subscribe for the rest of the CKA series, and the full write-up is on dev.to.